All right, so today's lecture is going to be memory, learning, and problem solving. My name is David. I'm one of the MCAT lecturers, and I'll be presenting this lecture today. So just let me know if I mumble or have a tiny lisp when I present. I recently lost a tooth, so just let me know if you need anything repeated. All right. So just a quick description on the course. It's a 15-week MCAT program that we're doing. We are doing Zoom lectures on different topics every Thursday, Friday, Saturday each week.
That mirrors the exact format of the real test. Typing your answers into our platform.
Sorry, I think someone's mic is on right now.
Yeah. Please mute your mics again.
So we're doing lectures every Thursday, Friday, Saturday at 8:30 p.m. EST. And then on Sundays at 8:30 p.m., we're doing office hours on Zoom also, if you have any specific questions or topics you want to go over with the MCAT tutors. So just some links for you guys if you want to join our group meet chat. If you want to post questions on there, usually we'll respond when we can. And then other people in the chat can help you out as well. And then, like I said before, we're recording these Zoom lectures and then we're going to post it on YouTube. This is the link for it if you want to subscribe and watch the videos on YouTube. And we also have a website, socraticmed.net, if you want to take a look at it. And then also we have an Instagram at socraticmed_. If you want to follow them, they'll give you daily questions and updates on the program. So just some learning objectives. So I'm going to go over, so we're going to learn how we create new memories and then store it in our short-term and long-term memory. And I want you guys to understand the different ways to learn new behaviors and change old behaviors. And also recognize the various problem-solving methods that are on the MCAT. Okay, so first topic we're going to go over is memory. So how we create memory is called encoding. So that's how we gather new information and consolidate it into what we know as a memory, something that we know. So there's two different ways that this happens. The first way is automatic processing. So that's when we gain information without much effort. We passively absorb it from the environment. So we're not consciously knowing that we are learning this information and picking up information from the environment, everything we see and hear. So that's the first method. And then the second one is controlled or effortful processing. So that's when we actively try to memorize information. So when you're studying, that's pretty much controlled or effortful processing, because you're actively forcing yourself to learn this information. It's not just something that we picked up from the environment. So those are two different ways. They differ because automatic processing, it's not much effort or conscious thought put into memorizing this information, while controlled processing, you're actively using your brain power and effort to memorize this information. But controlled effortful processing can also become automatic with practice and over time. So when you first start driving, you're obviously looking around the road, being careful, looking at your speed and everything. But once you have been driving for a while, it won't take much effort at all. You'll just be driving. You won't even know it sometimes. Any questions on that part? Okay, so next slide. So there's different types of encoding. So visual encoding is when we're taking in information through images that we see. So with our eyes, it's the weakest type of imagery because there's so much that we can see at once and it's hard to process everything at the same time. So it's the weakest type. And acoustic encoding is when we process sound information from our surroundings, and it's intermediate, but the the most powerful kind of encoding is semantic encoding. So that's information that we give a particular meaning and context, so something that is important to us and we relate to. So obviously that's the easiest one for us to encode and turn into a memory because we place a significant amount of meaning and context into it. So related to semantic encoding is a semantic network. So these are concepts that are linked based on a similar meaning and context. So when we learn something, if we already have information that is similar to the information that we learned, it's easier to remember it because we'll relate the new information that we learned to something that we know is important and we already know in our mind. All right, any questions on that? Okay, so there are a few different ways that we use to remember and consolidate information into a memory. So the first part related to the semantic encoding is a self-reference effect. So so this is a phenomenon that we recall information best when put into the context of our own lives. So whenever we gain information and we can relate it to something that we've already experienced, something in our life, it's easier for us to remember that information. And the next thing is maintenance rehearsal. So that's when you repeat information over and over again. So what you're doing currently while you're studying for the MCAT, you're repeating this information over and over again. You're keeping it in your working memory so you can move it to your short-term memory and then eventually into your long-term memory for when you take the MCAT. So many times we'll try to use things like mnemonics that help us memorize information easier. So we'll use like acronyms like LabRat, PEMDAS, stuff like that to help us remember more information. Or we use rhyming phrases, so certain like phrases that rhyme in order for us to make it catchy and we'll remember it better. So like a lot of like commercials, they use like things that rhyme or phrases that rhyme, so then we'll remember it in our head. So it's something like catchy that we'll remember in our head, and it's easier for us to remember it later on in the future. So all these different mnemonics, they provide organization to information. So we'll have a whole bunch of information, but if we can consolidate it into something small and concise that we can remember, it'll be a lot easier to remember in the long run. So there are a few different mnemonics covered on the MCAT. So the first one is called method of loci. So loci is Latin for like location. So what this mnemonic does is you associate a particular item on a list that you want to remember with a location on a route that you already know. So this one I don't really understand. I have never used this in my life, so I'm not sure how effective this is. But so pretty much you have a route that you memorize. So like maybe like the route from going from your bedroom to your basement. So on the way you'll pass like your bathroom, your kitchen, your living room, and you'll place use those to represent a particular thing that you're trying to memorize. So you can think of the bathroom as bathroom as like, oh, this amino acid, not glycine, and then your kitchen as alanine, and then your living room as phenylalanine, as tryptophan. So then along the route, so you just memorize your location and then the route that you're taking to a different location, and each item on the list is associated with a different spot on your journey. Yeah, like I said, I don't think that's a very effective way of studying, but who knows? Some people might like that. Another one is peg word. So that's when you associate numbers with an item that rhymes and resembles the number. So one, you could remember like 1 gun, 2 blue, something that rhymes with the number on a list. This one I also don't think is very effective, but yeah, maybe it works. And then the last one is like what I usually use, called chunking clustering. So that's when you take a bunch of separate elements and you try to group things with similar meaning and in a specific context. So if you have a bunch of items, maybe you'll want to organize them into like a specific color or a specific size, just so they have something in common that you can group them into when you're studying. All right. Oh, I don't know why there's transitions, but so there's different types of memory storage that we use. So sensory memory is everything we're taking in at this moment. So it's very fleeting. It lasts only about a second. There's iconic, which is visual memory, so everything you see, and then echoic, which is auditory memory, so everything you're hearing at the moment. So even though it's only lasting a second, you can have a detailed representation of your surrounding with precision. So if you close your eyes right now, you still remember specific things that you saw before with great detail, even though it's a very short amount of time. But so when we place like a specific meaning to a sensory memory, so when we pay attention to something, it will be turned into a short-term memory. So even that fades pretty quickly, it'll last about like 30 seconds. So most people that have a limited capacity, they'll be able to remember 7 items in their short-term memory. But that's like give or take. So it's called the 7 ± 2 rule. So if I give you a specific list of things and I'll tell you to take a look at it, you'll remember about 7 ± 2, depending on who you are as at the moment and how good are you at remembering a specific list. But you can increase the capacity of your short-term memory by clustering. So if you're grouping certain things together, you'll be able to remember more things, because instead of remembering the specific items, you'll remember the groups, and each group will have more than one thing in it. So you'll be able to increase the amount of things you can remember. And then you can also increase the duration by maintenance rehearsal, which I will go over later. Actually, yeah, so I went over that. That's when you repeat the information that you learn. So when you're studying, you're just constantly repeating it in order to increase the amount of time you remember for. So hopefully you remember it by the time you take your test. And short-term memory, it's stored in the hippocampus. So the hippocampus is primarily responsible for short-term memory. And then next is working memory. So that's when you keep information in your consciousness for manipulation. So when you're doing like math, or you're answering a particular question about a specific topic, that's when you're using your working memory. So you're taking something that was in either your short-term memory or long-term memory, and you're keeping it in your working memory so you can manipulate it. And then that's also supported by the hippocampus. So the hippocampus is responsible for working memory and also short-term memory. And then lastly, there's long-term memory. So if after maintenance rehearsal, so after you repeat the information enough times, hopefully it'll be moved from short-term memory to long-term memory. And that's amazing, because your long-term memory is a limitless warehouse for knowledge. So you can remember a limited amount of things. There's no limit on how much you can remember. And you'll be able to recall the information on demand if it's in your long-term memory. And so elaborate rehearsal, it's when you associate information that you learn to knowledge that you already have in your long-term memory. So it's kind of like the semantic encoding, where if this information, it relates to something important that you have in your long-term memory, you'll be able to memorize it easier, just because you placed meaning on it. And for long-term memory, it's stored in the cerebral cortex. So unlike the working memory or short-term memory, the long-term memory is stored in the cerebral cortex. So when you turn a short-term memory into long-term memory, your hippocampus will move the short-term memory to the cerebral cortex. Any questions on memory or storage at all? Okay, all right. I'll move on to the next one. So long-term memory, it's split into two different types. So the first type is implicit, or also known as non-declarative or procedural memory. So that's all the skills and conditional responses that you learn. So it's everything that you know how to physically do and behavior that you learned through your life. While the opposite, the other type is explicit or declarative memory. So that's all the memory that require conscious recall. So that's all like the non like physical actions that you learn or physical skills that you learn. It's the facts that you know and all the experiences you had. So yeah, and then explicit declarative memory is also split into two different types. So like I said, the semantic memory is all the facts and information that we learned over the years, while episodic memory is the experiences we have. So all the like emotions, memories, experiences that we've had over the years. And I put a good chart that splits long-term memory into this tree that separates all the different types of memories really well. So I would definitely use this chart to study long-term memory. All right, so next. So once you place the information into long-term and short-term memory, you want to retrieve it at some point. So to determine if you actually learned something, you have to retrieve it. So if you're able to retrieve it from your long-term or short-term memory, then you know you've turned it into a short-term or long-term memory. So you'll be able to retrieve the information whenever you need to. So the first thing is recall. So that's retrieving the learned information that you've had. So that would be like if you had a short-term response question and you were able to write out everything about that question, that's a good example of like recalling the information. While recognition, it's easier than recall because you just have to identify an information that you learned. So it would be like more like a multiple choice question where they present you with all the answers and you just have to look and see which one you recognize. So if you just recognize one of them, you'll circle that answer instead of actually recalling all the information. You're only recognizing it. So the next thing is spacing effect. So that's when if you leave a longer period of time in between studying, you'll have a greater retention of the information. So if you study something right now and then you wait like a few weeks to study again, it's better than studying it now and then waiting a few days and studying it again. So the longer amount of time you put in between studying, there's a greater retention of the information that you're trying to learn. And there's also something called priming, where recall is aided by presenting a word or phrase close to the desired semantic memory. So let's say I was trying to get you to remember something in Paris. I would start giving you things like the Louvre or the Eiffel Tower, something close to the memory that you had in order to like jumpstart your brain to remember that specific memory you're looking for. All right. And some other concepts, so related to priming, it's called spreading activation. So that's when other linked concepts are unconsciously activated when one concept is presented. So let's say I present the word blue to you. You'll start thinking of things blue, like the water, blueberries, stuff like that. So that's when I give you one concept and your brain automatically starts thinking of other concepts that are related to it. Like if I say like hot, maybe you'll think of like soup, summer, stuff like that. So that's very good because your brain like preemptively gives you other concepts that it thinks you might need when you're presented with a specific like word or phrase. And then so context effects, that's when your memory is aided by being in the physical location of encoding. So so let's say you're trying to remember something in Paris, some experience that you had years ago in Paris. If you went back to Paris, it'd be a lot easier for you to remember the experiences and emotions you've had in Paris instead of when you're back in the US. So that's when specific location affects helps improve your memory. And state-dependent memory in effect is when a similar mood or mental state helps aid your retrieval memory. So if you're trying to remember something sad, it would be a lot easier for you to remember it if you're currently sad. So if you were sad, it would help you remember other memories that you had when you were feeling a similar sadness in the past. But this also causes a persistence of mood. So if you're sad and you're remembering sad memories, you'd be even sadder because of the memories that it's bringing up. And then serial position effect. So there's two different types, primacy and recency. So primacy is when it's easier for you to learn pieces of information that were presented earlier. So primacy, like prime, the first, so things that you're presented earlier. While recency effect is you're able to remember things that were presented later on. So primacy is you remember the first part of the information that you learned, while recency is something you learned more recent, so the later part of the information that you learned. Any questions on the lecture so far? We have a question coming up. If anyone has any confusion or questions on the topics. Okay, all right, so I'm gonna go into the question. All right, so I'll give you guys a few minutes to read this question and do the click and answer. Oh, sorry, I labeled it 1, 2, 3, 4 by accident, but the answer choices will be A, B, C, D. So A is 1, 2 is B, 3 is C, and 4 is D. So I'll give you a few minutes to read this and click an answer. All the answer responses are anonymous, so take your best guess or hit no idea if you're not sure. Oh. Okay, so yeah, I'll give everyone like 15 more seconds if you want to put in your answer. Okay, I'm going to stop the poll now. Okay, so it looks like most people got it right. Choice B or 2. Yeah, so I guess recency effect is, this is like an example of recency effect. I just went over this, so most people got it right. Yeah, so since they were going over a phone number and the girl can only remember the last few digits of the phone number, it would be recency effect, because recency effect is when you learn, you remember the information that you learned latest, so the last few digits of the phone number. Classical conditioning, to answer choice 1, I'm gonna go over in a bit. And choice 3, encoding, is just learning any type of information, so it wouldn't be really the phenomenon that was shown. And then primacy effect is when you remember the first few digits of the phone number, which wasn't the case. She remembered the last few digits. Any questions on this problem? Okay, I'll move on to the next one. So I'm going to go over learning. So we're going to go over specifically learning new behaviors or changing an old behavior in response to a stimulus. So there's two different things. Habituation, that's when repeated exposure to the same stimulus decreases a response. So it's kind of like alcohol or drug tolerance. After repeated exposure to that specific drug or alcohol, you're gonna have you're gonna have a decrease in response to it. So like a less high or less drunk than you normally would if you than you normally would without drinking repeated amounts or using repeated amounts of that drug or alcohol. But then dishabituation is when you have a temporary recovery of the response to the stimulus after habituation occurs. So after habituation occurs, if you give it a good enough amount of time, if you are exposed to that stimulus again, you'll have another response to it even after habituation. It'll be temporary and it'll be a reduced response. So it won't be as high as you normally would if you were exposed to a stimulus before habituation occurred. So I'm going to go over 2 different types of learning: associative learning and observational learning. So first, I'm going to go over associative learning. So that's when you create an association between a stimulus or a behavior and a particular response to the stimulus. So there's a type of learning called latent learning. That's when you learn without reward given to you, but then you can spontaneously demonstrate the behavior after a reward is presented. So that's when you unconsciously learn a specific behavior without knowing, and it's not something that you would normally do, this behavior, but then after you're presented with an award, you spontaneously demonstrate it because you unconsciously learned it in the past. And then preparedness, so that's a concept where someone is predisposed to learning a specific behavior based on their natural ability. So it's not something that can be learned or taught. It's just something that they were born with, and they're able to learn this behavior or skill better. And then related to that, instinctive drift. So once you're born with the ability to or a certain behavior, it's difficult to overcome your instincts and either move away from that behavior or stop performing that behavior. And then associative learning is also split into 2 different categories: classical learning, classical conditioning, and then operant conditioning. So the first part I'm going to go over is classical conditioning. So that's when you take advantage of biological and instinctual responses to create association between unrelated stimuli. So classical conditioning, you take something that is biological, something that you were born with, and you use that to create a specific behavior that you're looking for. So, so first, an unconditioned stimuli. So that's when it's a certain stimuli that causes an innate or reflexive psychological response. Otherwise, it's known as the unconditioned response. So an unconditioned stimuli would be like smelling something good, like a food, and salivating. So it's an unconditioned stimuli because it's a biological response. You can't stop yourself. Once you smell good food, you'll start salivating, and the salivating part is the unconditional response. So it's not something that you learn, it's just something that you're born with. You didn't have to learn it or condition yourself to do it. And then neutral stimuli would be something that doesn't create any response at all. So it doesn't cause an unconditioned response. So it would be like if I waved a piece of paper in front of you, you wouldn't start salivating because of the piece of paper. It's neutral. It wouldn't really cause a response. But it can be a signaling stimuli. So that's when a neutral stimuli has the potential to become a conditioned stimuli. So it's something that normally wouldn't cause a specific behavior response, but because of classical conditioning, you can use it to create a conditioned stimuli. So conditioned stimuli is a neutral stimuli that causes a reflexive or physiological response after association, and that leads to a conditioned response to it. So the conditioned response is the learned behavior response after classical conditioning to turn that neutral stimuli that would normally cause no reaction or behavior to cause the conditioned response. Sorry, I said stimuli a lot of times. Does everyone understand how like each of these different stimuli are different from each other? Okay. If anyone has questions, just put it in the chat. Mark can help you, or just let me know later. So classical conditioning, we want to start with acquisition. So that's when you take advantage of the reflexive or not unconditioned stimulus to turn it. So you take advantage of the reflexive unconditioned stimulus to turn a neutral stimulus into a conditioned stimulus. So that's when you take a neutral stimulus that would normally cause no reaction, but when you pair it to a unconditioned stimulus, you can turn it into a conditioned stimulus. But so as I went over earlier in the lecture, so extinction is related to like habituation, where the conditioned stimulus has no response after a while. So normally the conditioned stimulus that was learned would cause a response, but after being exposed to the conditioned stimulus, after being exposed to the conditioned stimulus without the unconditioned stimulus, no response would occur. But something called spontaneous recovery can occur when the extinct conditioned stimulus, so the conditioned stimulus that was habituated and caused no response, it can cause a weak conditioned response after a period of time. So it's like when you this like response that you learned after you leave it for a while, and then you re-expose them to the conditioned stimulus, it would lead to a weak conditioned response, even after extinction and habituation. And then a phenomenon known as generalization is when a stimulus similar to the conditioned response can produce a conditioned, something similar to the conditioned stimulus can produce a conditioned response. So it's like when you're exposed to something similar. So if I were to ring a bell, imagine like a bell was the conditioned stimulus, something similar to the bell, like a triangle or another instrument that plays a sound similar to a bell. Is when that similar stimulus also creates a response creates the conditioned response. So it's a broadening effect. It's when something similar to the conditioned stimulus causes the conditioned response. And the opposite is discrimination. So when you learn to distinguish between two similar stimuli. So that would be when you ring a bell and you are able to distinguish two different types of bells. So only one specific type of bell would be able to cause the conditioned response. So that's the opposite. It's not a broadening effect. It's more of like a narrowing effect where only a specific stimulus would cause the conditioned response. Okay. So the classic example of classical conditioning is Pavlov's dog. So Pavlov, he experimented with dogs. So he noticed that if you place food in front of a dog, it would start salivating like we do too. So the food would be the unconditioned stimulus because the dog didn't have to learn to salivate when he sees food. And so when you presented the unconditioned stimulus to the dog, there would be a response, which is salivation. And that salivation response is the unconditional response because the dog didn't have to be taught to salivate when it saw food. So this is before any conditioning happened. So we have the unconditioned stimulus that naturally and biologically causes the unconditioned response. So in his experiment, he noticed that neutral stimulus, which is the bell, caused no response. So no salivation occurred, which is something that you expect because normally a dog would not start salivating when you bring a bell in front of it. So the neutral stimulus caused no conditioned response. But during his experiment, when he was doing the conditioning, he presented the food to the dog, but whenever he presented food to the dog, he also rung a bell. So when he gave the food to the dog, he also rang the bell. And so these two were paired with each other. So the unconditioned stimulus, which was the food, was paired with the neutral stimulus, which was the bell. So because the food was presented to the dog, there was a response, which was salivation. So the food paired with the bell caused the unconditioned response of salivation because the dog was presented with the food. But after a while, after repeatedly presenting the food and the bell to the dog, he noticed that even if he didn't present food to the dog, if he just rang the bell, the dog started salivating. So now the bell has become the unconditioned. No, sorry. The bell has become a conditioned stimulus. So after conditioning, a bell, which would normally be a neutral stimulus because it causes no effect to the dog, has become a conditioned stimulus because the dog starts salivating whenever he or she heard the bell being rung. So that would mean the bell can now cause a conditioned response of salivation. So the dog has learned to pair the bell with food. So whenever the dog heard the bell, he automatically thought that he was getting food because during conditioning, he was presented with food and a bell at the same time. So after conditioning, the bell, which is the conditioned stimulus, causes a response of salivation, which is the conditioned response because of the conditioning that the dog received when being paired with food and the bell when it was being fed. So that's like the classic example of classical conditioning, Pavlov's dog. Any questions on this part?
Hi, David, I had a question. Is it
Sure.
important that we deconditioned the conditioned stimulus after experimenting so that maybe the dog won't keep salivating even after, just because he hears every bell? Like at some
Yeah.
point, did he decondition the dog? Because then that would be sad that
Yeah,
every time
so
he hears the bell, he'll salivate, right?
yeah, so that would be an example of like extinction or habituation. So after a while, if you just feed the dog normally without a bell, the dog will start to forget that he or she associates the bell with food. So after you present the dog with enough times with just the food, it'll start to forget that it'll start to lose the conditioning that it had. So the bell will slowly start to lose its conditioned stimulus and the response related to it.
And that's called dehabituation?
It's called habituation of the response or extinction. So habituation is when you're exposed to something over and over again. So that would be like just the food, not the bell. And then extinction is when the dog forgets the conditioned response that it learned to the conditioned stimulus, the bell. So the dog starts to forget that it associates the bell with food and won't start salivating anymore. But if you bring the bell back and you ring the bell again, it'll have like a slight response to it just because it did have that conditioning. So it won't salivate as much as when it did right after or during conditioning, but it'll still salivate a little bit if it still remembers that the bell was associated with the food. Yeah, that was a good question, Opal.
Okay, one more. When you were talking about learning and you described the working memory, long-term memory, and habituation, there were a bunch of different descriptions. So what would be the best definition of me sitting down listening to you passively? Is that going into my short term, or is that in the cerebral cortex or hippocampus?
Yeah, so
What's passive listening? Where would that fit?
so Pavlov, do you mean like what this like what the bell would be for the dog?
No, never mind. This was couple slides ago. I'll ask at the end. This was just all these definitions of learning, how you gave us short-term working memory, long-term memory.
Oh yeah.
So I was just wondering, with us sitting down passively and listening, what type of learning are we doing by passively listening to you?
So that would be classical conditioning. It would be more like observational learning, which I'm going to go over in a little bit. So yeah, you're just sitting down watching me right now, so it's more like observational learning.
Okay.
You're not physically being exposed to like a specific stimulus.
Mm-hmm. Thank you.
No problem. Sorry. Hold on one second. Okay, sorry about that. Yeah, so then the other part of associative learning is operant conditioning. So that's when you link behaviors with consequences to alter the frequency of behaviors. So it's related to behaviorism, which is the theory that all behaviors are conditioned. So this is the concept that all the behaviors that we exhibit right now is something that we learn throughout our lifetime. So there are a few different ways to alter the frequency of the behaviors. So the first one is reinforcement. So that's when you're actively trying to increase the likelihood that you or someone else will perform this behavior. So we would use something like a positive reinforcer that increases behavior by using positive incentives or consequences. So a positive reinforcer would be like your parents giving you money every time you perform like a chore or help them with anything. So they're using something positive to increase the behavior. So they're trying to use the money to get you to perform more chores and help out more around the house. While a negative reinforcer also increases behavior, but it's by removing something bad. So positive and negative reinforcers, they both increase the frequency of a behavior, but a positive reinforcer does it by adding something positive as a good incentive, while a negative reinforcer removes something bad. So it's like, oh, the negative reinforcer increases behavior by removing something bad that you currently have and removing it. But you just, it's important to remember that both the reinforcers, they increase behavior, but through different means. A negative reinforcer would be sort of escape learning, where the role of behavior is to reduce existing unpleasantness. So escape learning is when you try to escape a bad condition that you're in right now by performing a specific behavior. While avoidance learning is like in the thing avoiding. So you're avoiding you're trying to prevent some pre-existing unpleasantness. So you're trying to avoid a bad consequence. So escape learning is you already have the bad consequence right now and you're trying to reduce it or eliminate it. While avoidance learning is you're not currently in that bad condition, but you're trying to avoid being in that bad condition. And then the reinforcers can be split up into different kinds. So primary reinforcer. So that would be any like biological stimulus that we naturally respond to. So we don't need to learn. It's just something that's like reflexive and physiological. So some examples of that would be like food, drink, and pleasure. You don't have to be taught to respond to food and drink because that's something that we naturally desire and try to strive to get. While a conditioned secondary reinforcer is when we use conditioning to make a non-reinforcer cause a response. So those examples would be like money, grades, or a specific title. So normally money and grades wouldn't cause someone to perform a specific behavior. If you gave money to someone who knew nothing about the concept of money, they wouldn't perform a behavior just because you gave them a piece of metal or a piece of paper. So that's something that we learn to have a response to. So because everyone here, we learned that money is valuable, grades are valuable, we're trying to work hard. So we would work hard for money and we would work hard for grades because we learned that those are important in life. But someone who has no concept of money or grades would not work just because we tell them that they're going to get a lot of money or a lot of grades. So that's something we learned. It's something conditioned, while primary reinforcer is just something that naturally humans and animals respond to. So that would be like the basic biological needs that we have. And then the other part of operant conditioning is punishment. So that's when we use conditioning to decrease the behavior. So both positive and negative punishment are used to decrease behavior. So positive punishment, we add something unpleasant to reduce the behavior. The specific behavior that we want to reduce, we'll try to decrease it by adding something bad. So adding like so we can discourage like bad behavior in school by threatening them with detention. So it would be a positive punishment. We're trying to decrease this bad behavior by adding detention and staying after school and other stuff like that to help decrease it. While negative punishment is reducing behavior by removing a stimulus. So parents could try to encourage good behavior by so they would try to encourage them not being like tardy to school or getting bad grades by removing like their phone, TV access, internet access. So we're decreasing behavior by removing something to make it bad and then positive for them in order to reduce that behavior. So both positive and negative punishment decrease behavior. That's important to know. And then the other learning that's different from associative learning is observational learning. So that's when we learn new behaviors or change our behaviors by watching other people. So an important concept for observational learning is modeling. So we learn acceptable behaviors from watching people in our lives. So usually the first people that we model would be our parents, and then maybe teachers in school, and then role models later on in life. And an important part of our body that is used in observation learning is a specific neuron called mirror neurons. So these neurons are in the frontal and parietal lobe of our cerebral cortex. So these are important for observational learning because they're fired both when watching and performing an action. So whenever we're watching someone perform an action and we're physically doing the action, the mirror neurons are activated. So think of mirror as like reflecting back at each other, reflecting back the image. So whenever we watch someone do it and we're personally doing it, we're trying to mirror them. That's when the mirror neurons are activated. So this would be used when we feel empathetic. So when we're feeling the same emotions as someone, we would use mirror neurons. So if you're feeling sad because someone else is feeling sad, that would be the mirror neurons working together to create empathy. But then motor processes, so like when we're trying to copy someone else, so we're trying to copy someone's action, mirror neurons would also be used for it because we're trying to mirror their actions. We're watching them, but then performing it at the same time. So they would perform like a dual action. Okay. Any questions on that before I open the poll for the question? I think someone's mic is still on. Sorry. If you can just mute that. Okay, thank you. Okay. Yeah, if anyone has any questions, I'm gonna give you guys this question and I'm gonna start the poll. I'll give you a few minutes to do the poll, do the question, and take a look at the question. And if you don't know the answer, you can always click the last choice, but everything's anonymous, so give it your best shot. All right, I'll give everyone a few minutes for this. Okay. Give everyone like 15 more seconds if you want to put in your final answer. Okay, I'm gonna stop the poll now. Okay, looks like most of you guys got it. Choice A. So yeah, it would be the conditioned response because normally, if you look at the time, you wouldn't automatically have a sudden craving for coffee. But because she normally drinks coffee at a specific time each day, she's conditioned herself to want to drink coffee at that time. So normally looking at the clock and seeing it's 8 o'clock would not want someone to drink coffee if that person normally doesn't drink coffee at 8 o'clock. But because Mary drinks coffee at 8 a.m. every day, she conditioned herself to want to drink coffee at that specific time. Yeah, does anyone have questions on that one? Any problems? Okay, all right. I'll move on to the next part. So problem solving. So a few different types of problem solving that are on the MCAT. So the first one is trial and error. So that's like the basic type of problem solving. That's when you just try every possible solution until one works. But that's only effective if there are a few possible solutions. So if you have like a 4-number passcode and you remember the first 3 numbers, you can keep trying the different numbers for the last one. But that would only work if you have only a few possible answers to that problem. So that would only work a small percentage of the time. So next type is algorithms. So that's when you use like a specific formula or procedure that is known to solve a certain type of problem. So it'd be like equations that we use in physics or chemistry, things that we know will give us the answer if we have the necessary information and the right equation. So that's like more like cookie cutter, like if you have specific things and a specific formula to use, you can use that. But most of the time you won't have that either. So we would have to use the next two, deductive or inductive reasoning. So deductive reasoning, also known as top-down reasoning, that's when you start from a general set of rules and you work your way down. So you take whatever you learned. So you take what you learned in the past, everything you know about this problem, and you work your way down. So you start from like a general set of rules and everything you know so far about it, and you use that to draw conclusions on the problem that you're given. And the opposite, so deductive reasoning, I think it as like decrease. So you start from the bottom and you slowly go down. So you start from general, and then you move your way down to the keep narrowing it down until you reach your answer. So I think of it as like decrease. You start from the bottom and you start from the top and you work your way down. Inductive reasoning is the opposite. So that's when you start from the bottom and you work your way up. That's why it's also known as bottom-up reasoning. So that's when you take all the information that you were given and you work your way up to create a general set of rules or generalizations. So I think of inductive as like increasing. So you start from the bottom and you slowly use all the information you have to build up your answer. So those two are important. They're like opposites of each other. Deductive from top and down, and inductive bottom and up. Okay, any questions on this part? Okay. And another type of type. It's more like a easier way to answer questions. It's called heuristics. So that's when we use simplified principles to make our decisions. So it's like using like shortcuts and generalizations, or like stereotypical answers to make our decision. So the availability heuristic, that's when we decide how likely an event is. We do it by how easily similar things can be imagined. So that's when we make a decision by thinking about like similar instances that we can imagine. So availability, I think of it as like when you think of all the available like similar available examples, and we use that to decide how likely an event is. So let's say so I like to think of it as like, say you work in like an ER, you'll obviously think that it's very likely that someone will have a heart attack just because of where you are. But if someone doesn't work in the ER, they wouldn't think that a heart attack is like a pretty common thing that people normally have. So heuristics are good, but it can create like false circumstances and make you make bad decisions. So everything has to be taken with like a grain of salt, pretty much. So heuristics are good if for certain things, but it's also not wise to 100% trust them. So representative heuristics, that's when you sorry, I misspelled that. When you categorize items on a basis of whether they fit a prototypical or representative image of the category. So representativeness is when you're given like a certain concept or topic, and you automatically think of the prototypical or stereotypical representative of that category. So when I say, I don't know, when I, what's an example I can give? Yeah, so when I like, if I gave you like someone who's like, if I said like someone who's rich, maybe you'd think like they wear like a suit and tie or like fancy clothing, like designer clothing, even though that might not be the case. Rich people don't always like dress like that, but maybe that might be like the thing that you think of when I mention like a rich person. That would be like the representative heuristics. So sometimes it could be right, but don't trust it 100% of the time. So that classic example of when heuristics are not 100% reliable is the base rate fallacy. So that's when prototypical and stereotypical factors are used instead of numeric actual information. So that's when you ignore the information presented in front of you and use the stereotypical or prototypical image that you have of a specific topic. So going back to like the ER topic, it's like when if you ask an ER doctor what is the likelihood of someone having like a stroke, they would say maybe like 30% because they have a lot of people coming in with strokes. But the actual number could be like 12%, but the ER doctor wouldn't believe that's 12% just because they work in a hospital and they see strokes all the time. So they're more likely to believe the own number that they made up 30% than the factual and actual number of like 12% that a study found. So it's easy to use heuristics to solve like a problem, but you always have to know that not everything can be like put into like a square. Not everything fits into the stereotype or prototype that you think of in your head. So just always keep an open mind. All right, and any questions on that before I go to the next question? Anything I can clear up for you? Okay, all right, I'll go to the next question. So I'll give everyone a few minutes for this question too. Which of the following is an example of an algorithm? All right, I give everyone like 20 more seconds if you want to put in your final answer. Okay, I'm gonna end the poll. Yeah, so mostly everyone put D, and that's the correct answer. Yeah, so all these are an example of an algorithm. So it's like a preset set of procedures or formula for completing a certain action. So building instructions for a desk, yeah, so instructions already preset, pre-made instructions for a desk. It would only work if you were given instructions for a desk and you're given the pieces for a desk. It wouldn't work if you were given a chair and the instructions to build a desk. It would, so they're like pretty cookie cutter. It will only work if you have all the necessary material. And so, same thing for a baking recipe. That's a predetermined amount of like ingredients that you need, and formula for math equation. That's something that was already given to you or you learned, and you just have to apply it with the right variables and units for the equation. Yeah, so all these, the three above, would be an example of an algorithm. Any confusion or questions about this question?
Yes, David. Yeah, so I don't see how baking cookies is solving a problem. Like a desk could involve mathematical, measuring and stuff like that. But I guess cookies, I guess you're measuring. So is that the problem?
It's not like necessarily a problem. It's just like a specific way to solve a problem. So I guess the problem would be like you're hungry and you want cookies, and the recipe is solving that problem by giving you the instructions to make a cookie. So an algorithm is just like something that is like already like predetermined and given to you. It's known to like give a certain result if you have the necessary ingredients or materials or information.
Mm-hmm.
So it's not something like trial and error where you have to physically you have to go out and like find the right answer. This is like it's something given to you. You just have to follow these like descriptions or instructions.
Okay. Yeah. Formulaic. Okay.
Yep. Yeah. Any other questions? Okay. Yeah. So that's all I have for everyone today. Any part of the lecture you wanted me to go over, or any questions you have on this lecture?
I have another question, David.
Sure. Oh boy.
The question has to do with.
Sorry, Opal, you're kind of echoing a little bit.
Are you hearing me now?
Yeah. Yep, you're good now.
So you mentioned about the lady drinking the coffee every day at 8 o'clock.
Yeah, let me hold on. Yeah, this question.
How do you explain addiction? Like if somebody's addicted to alcohol, is that a conditioned response or stimulus? Addictions to even food or something? What kind of response is that?
So would it be like a conditioned response? It's more like, so a conditioned response would be something that like normally doesn't cause a response. So it would be like a response that normally doesn't happen because of a neutral stimulus. So you know how, so like in this question, normally if I like check my watch and it's 8 a.m., I wouldn't want to drink coffee. But because Mary drinks coffee every day at 8 a.m., she learns to associate 8 a.m. with wanting coffee. So an example of like addiction would be like if you normally drink, but then you also eat like chips while you drink. So if you eat chips while you drink every day, after a while, if you just eat chips, you're going to want to drink just because you're associating having chips with drinking.
Okay, so in that scenario, which is the condition?
Sorry, well, you're so the conditioned response
which one is the unconditioned and which one is the conditioned?
Well, so the conditioned response would be like wanting to drink, and the conditioned stimulus would be the eating chips. So like if I were to start eating chips, I wouldn't want to like drink every time I eat chips. But because someone who eats chips whenever they drink, they'll want to drink whenever they have chips, even if they're not drinking at the moment.
And the time, would that be unconditioned stimulus? The timer?
Well, for the unconditioned stimulus, so the timer would be unconditioned stimulus if before the conditioning. So before when Mary was like a child, the time would be an unconditioned stimulus because when she was 5 years old, she didn't drink coffee when she just woke up and it was 8 a.m. But after conditioning happened, because she drank coffee every day at 8 a.m., she would want to drink coffee whenever she notices it's 8 a.m. So the time 8 a.m. was an unconditioned stimulus, but through conditioning throughout the years of her drinking coffee at 8 a.m., it became a conditioned stimulus because it caused her to start wanting coffee whenever she noticed that it was 8 a.m. Does that make sense, Opal?
Thank you.
No problem. Okay. Any questions about anything else? Any other questions? right, I'm gonna stop sharing. Yeah, so like I see in the chat, exactly what Mark said. Top-down processing is when you see something as a whole rather than parts. And then the opposite would be bottom-up processing. So we read each individual word, but when we combine each individual word, we get a paragraph. So even though we're reading each individual word, we're getting like the main idea of the paragraph when we use bottom-up processing. Sorry, Anna wanted me to share the screen. Is there a specific slide you wanted me to go to, Anna? Anna, did you have a specific question about this lecture?
No, I could only see your face. Are you done?
Sorry, what?
Are you done with the lecture?
Yeah, so I'm done with the lecture right now. I'm just going over any problems or questions that anyone has about this lecture right now.
Oh, okay, no problem. I thought we were still having a lecture.
Oh, no, sorry.
Okay, no problem.
One more question. I was confused with your negative reinforcement. Could you say that
yeah.
escape learning, avoidance, and primary were examples of negative reinforcement? Did they all under negative reinforcement or they're separate?
Sorry, which you said reinforcement?
Yeah, and then you went into the 4 types of negatives. Like those, are they not that? The next slide. Avoid, yes. Are those 4 types of negative reinforcement?
Oh, no. No. So these are just the just like an explanation more about operant conditioning. So escape learning and avoidance learning are kind of related to like negative reinforcement, where yeah, so escape learning and avoidance learning are kind of like related to negative reinforcement, where we're trying to remove something bad in order to increase behavior. So escape learning, we're trying to increase or decrease learning by reducing. So we're trying to increase like behavior by reducing existing unpleasantness, which is related to negative reinforcement, because that's what a negative reinforcer does. It increases behavior by removing something bad. So let's say you're living in like a terrible house. You're gonna try and increase your behavior of like working hard, earning money in order to try to move out of the house. So that would be trying to move something like a bad condition, which causes you to increase a specific behavior. So escape learning would be a type of learning related to negative reinforcement, because you're trying to escape a current like state of unpleasantness or discomfort. So something bad you're currently experiencing right now. And then avoidance learning, so that would be like if you're living in a nice house and you're working hard in order to prevent yourself from losing the house, losing your nice house and having to mortgage your house and move into a worse house or renting like a bad place. Does that answer your question, Hopeful?
Yes, yeah, because I thought they were all negative, but you're saying they're just examples of negative.
Yeah, yeah. So they're just examples of what type of learning can be used with a negative reinforcer.
All right, great, thank you.
No problem. Okay. Anyone else have any questions or problems they want to go over about this topic. No problem. Thank you everyone for attending today. Hopefully it helped. All right. Yeah, if no one has any more questions, we can end the lecture here. If you have any questions about this topic, you can put it in the group chat or message me on GroupMe, and I'll try to help you out when I can.
Will I be able to listen to this again on YouTube immediately?
Oh yeah, so